Hello, students. Let me ask you something. Have you ever watched a cricket ball speeding toward a batsman or a moving car screeching to a halt? What makes these moving objects powerful? That's where the concept of kinetic energy steps in. Kinetic energy is the energy possessed by a body due to its motion. Simply put, anything in motion carries energy. That's kinetic energy. The faster something moves or the heavier it is, the more kinetic energy it holds. For example, a bullet moving at high speed can penetrate a wall, while the same bullet at rest does nothing. That's kinetic energy in action. Kinetic energy is a scalar quantity, which means it has magnitude but no direction. You'll come across kinetic energy everywhere, from flying footballs to falling meteors. So let's get mathematical. The formula for kinetic energy is Ke equals 1 divided by 2 multiplied by m multiplied by v squared, where m is the mass in kilograms and v is the speed in meters per second. As you can see, kinetic energy increases with the square of velocity. That means doubling the speed gives 4 times the kinetic energy. This is why speeding vehicles are far more dangerous. Even a slight increase in speed drastically raises the impact energy. And since mass is directly proportional to, heavier objects carry more kinetic energy at the same speed. Let's derive the formula now using the work energy principle. We start with the definition of work done. That's force into displacement. Now, using Newton's second law, we substitute force as mass into acceleration, and displacement using equations of motion. So the derivation becomes Ke equals m into a into s. Now, using the kinematic equation, v squared minus u squared equals 2as, we simplify to get Ke equals 1 divided by 2 multiplied by m multiplied by v squared. There you go. That's how we arrive at the kinetic energy expression using first principles. Now here's an important insight. The change in kinetic energy of a body is equal to the net work done on it. This is called the work energy theorem. Mathematically, it is expressed as change in Ke equals 1 divided by 2 multiplied by m multiplied by v squared minus 1 divided by 2 multiplied by m multiplied by u squared. Here, v is the final velocity and u is the initial velocity. This equation helps us understand how much energy is gained or lost due to acceleration or deceleration, whether it's a car speeding up or a stone falling under gravity. Let's now explore the different types of kinetic energy. Kinetic energy can be classified into 3 main forms depending on the nature of motion. First, we have translational kinetic energy, which refers to motion in a straight path, like a car moving down a road. Second, rotational kinetic energy, which occurs when an object spins around an axis. Imagine a spinning top. And third, vibrational kinetic energy, which is the back and forth motion around a mean position, like the vibration of a tuning fork. Now let's look at some examples. A spinning top clearly demonstrates rotational kinetic energy. On the other hand, a vibrating tuning fork exhibits vibrational kinetic energy. Some objects can even have more than one type of kinetic energy at the same time. For instance, a rolling ball shows both translational and rotational kinetic energy together. And finally, at the molecular level, all 3 types, translational, rotational, and vibrational, may exist simultaneously, especially in gases and liquids where atoms are in constant motion. Now let's understand how kinetic energy and momentum are related. Both of these quantities depend on mass and velocity, but they represent different physical ideas. Kinetic energy measures the energy of motion, while momentum tells us how difficult it is to stop a moving object. There's a powerful formula that connects both. Kinetic energy can be expressed in terms of momentum using the equation kinetic energy equals momentum squared divided by 2 times mass. That is, Ke equals p squared divided by 2m. In this formula, p stands for momentum, which is calculated as mass multiplied by velocity, or simply p equals m times v. This relationship becomes very useful in physics, especially when analyzing collisions, where momentum and energy behave differently under various conditions. Finally, this equation also highlights something interesting. Momentum is a vector quantity, meaning it has direction, while kinetic energy is a scalar, meaning it does not. This link between a vector and a scalar gives us deeper insights into motion. So to wrap it up, kinetic energy is the energy of motion. It depends on both mass and velocity. The key formula, Ke equals 1 divided by 2 multiplied by m multiplied by v squared. We derived it using the work-energy principle and saw how it connects with momentum through p squared by 2n. The work-energy theorem tells us that work done is the change in kinetic energy, a fundamental rule in mechanics. I hope this session helped you appreciate how moving objects store and use energy. From rolling balls to orbiting satellites, kinetic energy drives the universe. See you next time with another exciting concept of physics.